Hello everybody. So today we are going to formally introduce the normal distribution. Normal distribution is a distribution that is continuous. That's the first thing. The random variable you'll be working with happens to be continuous, not discrete. And the second thing is not only that it is symmetric, it looks like a bell-shaped curve. And normal distribution, any variable, any random variable, continuous random variable that tends to represent something that is natural in the world tends to follow a normal distribution. You could think of SAT scores, verbal, math, GRE for graduate students, people's heights, people's weights, number of days of pregnancy, the circumference of people's heads. Let's say you wanna build helmets, and if you measure people's heads, some have small heads, some have big heads, and the majority are average. And if you plot those data points, it will follow a normal distribution. It will follow what we call a bell-shaped curve. Now, that is not a reason for you to assume that the distribution is normal, just because it tends to be natural. There are ways to test whether or not a distribution is normal, which is not what I'm going to do today. I'm going to hold off on that discussion for later. For now, I'm going to assume, I'm literally just telling you, assume it is normal, okay? Now, with the normal distribution, the two parameters you need to know, the only two things you need to know, assuming the distribution is normal, is the mean, which is the center of the distribution, right? And the standard deviation. Recall from our previous video when we discussed the z-scores, the point of inflection, which is probably somewhere in here. In here, the curve is concave down, concave up. Somewhere in here is the point of inflection, which you will see or you have seen in calculus. And that distance is 1 standard deviation. So the mean tells you the location of the bell-shaped curve, right? And the standard deviation tells you the shape of the bell-shaped curve. So if I have a low standard deviation, the bell-shaped curve might look like this, right? If I have a large standard deviation, it might look more flat. So the standard deviation controls the look of the bell-shaped curve, and the mean controls the location. Is it here? Is it here? Is it here? Is it here? Think about circles, okay? What do we need to know about circles to identify a circle? What do you really need to know? You need to know the center, and you need to know the radius, right? If you know the center and you know the radius, you know everything you need to know about circle. Why? Because the center, well, there are two reasons. One is the formula for the equation of a circle relies on x0, y0, and relies on r, the radius. In other words, if I know my center and I know my radius, I can control this relation. I can do anything I want to do with this circle. Similar, and the other reason, of course, is the center tells me the location of the circle, doesn't it? Is the center here? Is it here? Is it here? That tells me the location. And R tells me the size of the circle. So if I go on campus and I throw like 1,000 big hoops everywhere, and they are all different. If I tell you the location and I tell you the size, everybody can come back with the same hoop, right? Because they all look alike, they're all in different locations, and some of them are small, some of them are big. But if I tell you the particular location, because on a particular location, the location is not enough, because you could easily have a circle within a circle, and they all have the same location. So it's not enough just to talk about location. I also need to know the size. The radius gives you the size. The same thing happens. If I know my two parameters, mu and sigma, I know everything I need to know about the normal distribution, as you will see in a second. Okay? So here is a situation. The IQ scores follow an approximately normal distribution. I'm giving it to you. You don't have to test it. We don't know how to test it yet anyway. And I'm giving you the mean. So on average, people have 110 points on their IQ score with a standard deviation of 25. So just based on the previous conversation, I gave you your two parameters. And if you know these two parameters, you can answer any question you want, okay? So here is the first question. What percent of people have scores above 90? Now, we can't do ogive here. This is a normal distribution. It actually turns out to be much nicer. So let me share with you a couple of things first so we can answer these questions. When we deal with the normal distribution, there are two functions that we need to know. Norm CDF and inverse norm. These are functions. Don't get scared. These are functions. Call this function G and call this function F. What does norm CDF do? It takes location. This is norm CDF function. It takes location and it returns area. Area or probability or a percentage or a percentile, whatever you want to call it, okay? That's what this function does. It takes location and it produces an area. Inverse norm does the opposite. It takes an area. Inverse norm takes an area and it produces location. Okay? In other words, it's this is inverse norm. It's like F and F inverse, isn't it? So think of this as F and think of this as F inverse, right? One takes location to area and the other one goes back from location, from area to location. Okay? So let's go back here. So imagine, so here is the question. What percent, I'm looking for area. What percent of people have scores above 90? So here's my 90. 90 is just to the left of 110. This is 25. So if I subtract 25, I'll get to 85. And 90 is somewhere in here. I don't know precisely what it is, but let's say it's here. And what I'm interested in is what is this area, right? What is this area representing a score of 90 or above, or actually just above 90? No, it actually does not matter. It turned out that it doesn't matter if it is above 90 or at or above 90. I'll address that separately, but I'm interested in figuring out if you have an IQ score of 90 or above, what is that area? What percent of people have scores above 90? So the answer is so simple because we can utilize the graphing calculator. Okay, so here is the question. The probability that X is more than 90. My random variable here is X, stands for IQ scores. Okay, above 90. And what you need to do is enter three things. Your two parameters for sure. We're always going to need mu and sigma. Okay, but up front, you need to put in the interval. Now, visually, this interval, X more than 90, looks like this. Sorry. I don't draw well. Okay, here is 90, all the way to infinity, right? So we just want to say X more than 90. That's what that interval means. The problem, of course, on the TI does not take infinity. So you just have to write 90 all the way to some giant number, large number. I wrote 100 million. Feel free to write 1,000 or 2,000 or 100,000, I don't care. I use exponents so I don't have to write too many zeros. And you do norm CDF of my interval, mu, sigma, and that should give me that area. We knew it's going to be more than 50% because 50% represents 110 score or more. 110 is the median or the mean. They're both same. So we knew it's going to be more than 50%. Turned out to be 78.81%. Okay, now how do you put this on your calculator? It's very simple. You turn on your calculator, go on second vars, which is distribution. Click on number 2, and you will see normal CDF. By the way, normal CDF stands for, norm CDF stands for normal cumulative, I'm accumulating. I'm not saying P of X equals 90, okay? Cumulative density function. I'll talk about the word density later. So norm CDF stands for normal cumulative density function, interval mu sigma, and you got your percents. Okay, let's do another example. Similar, I'm just changing numbers. I'm going in the opposite direction. Notice before I do the problem, I draw a picture. Okay, you've got to draw a picture. Label your x-axis, it's IQ scores. Make sure you label your two parameters, the mean and the standard deviation. And I would suggest you put the title here as well. Okay, always have a title. What percent of people have scores less than 100? Less than 100. Once again, I draw my picture to the right. Here's my picture. Here's my mean. Here is my standard deviation. Now 100 is to the left of 110, so it's somewhere in here. And I'm interested in this area. Okay, well, we know what to do. Always begin with the question, P of X less than 100. So that means norm CDF, interval, mu, sigma. What is my interval? I am going from negative infinity all the way to 100 non-inclusive. It turns out to be, it doesn't matter if it is inclusive or non-inclusive. And I'll talk about that later. So you're going to go from a very large negative number. I chose negative 100 million. I just copy this number, put a negative sign. All the way to 100, mu, sigma. And I got approximately 34.46%. Right? What it means, of course, is if somebody has an IQ score of 100, that person is in the 34.46 percentile. Isn't that true? In other words, this person is smarter than about 34.46% of the people out there and less intelligent than the remaining, which is 55.54 or something percent, okay? So that's what that does. Okay, now, so it's the same problem, okay? I just changed the direction so you know how to handle the interval. That's why I did this problem, okay? This interval goes from 90 to infinity, and this one goes from negative infinity to 100, okay? Now, let's move to inverse norm. In other words, I am asking you to tell me an IQ score that represents a specific location area. So remember, inverse norm takes you from area to a particular location. This is called the inverse norm. Inverse norm is the inverse function of normal distribution. And but you really need to pay attention now, because there is a little problem. It seems to me that if I use inverse norm, clearly I'm going to use mu sigma again, because that tells me location and that tells me the shape of the distribution. Is it thin? Is it wide, right? But in here, I would have to write an area. It seems to me that's what should happen, and that is exactly what happens, except one thing. I'm looking for the middle 68%. The middle 68% means this area is 68%. I'm looking for actually two locations. I'm looking for an interval. I'm looking for an interval that represents two locations where the middle is 68% area. Make sense? The problem is I wrote 68%, But in here, I did not write 0.68, and I did not write 0.68. There is a reason for it, so I really need you to pay attention. Whenever an area is given to you, and you're looking for location, let's say I'm looking for this location, you have to enter the area to the left of the location, the entire area to the left of that location. If I'm interested in this location, I have to enter that area. If I'm interested in this location, let's put it in green, I have to enter that entire area. So in our case, I'm interested in the middle 68%, right? The middle 68% is here. So if I'm looking for this location, let's call this the lower end, and this is the upper end. If I'm looking for this location, this endpoints, I have no rights to enter 68%. I have to enter this area. Well, if this entire area is 100% and this is 68, that leaves me with 32% to be split in half because these are equal. So this is 16%. So if I'm interested in this location, this is the area I have to write. And that is why for the lower bound, for this particular location that I'm interested in, I have to enter 0.16. You really need to remember not to write 0.68. It's 0.16. And then, of course, mu and sigma. And that gave me that location, which is 85.139. Of course, we knew it's going to be less than 110, right? So this is 85.139. Now, in order to find that location, which is the upper bound, inverse norm, mu sigma for sure, they don't change, but that location has to be, that area has to be 0.84. Think about it. If I'm interested, I'll do it in blue. If I'm interested in this location here, I have to enter this area. And this blue area is the 68% plus 16%. Isn't that true? Which is 84%. Okay, so you put in 84% here, mu sigma, and you get the answer. Therefore, to answer the question, in what range do the middle 68% of all IQ scores lie? The IQ scores of the middle 68% lie between 85.139 and 134.861. Okay, that's how you do it. Before I conclude, let me just show you a different method, and I'm sure you can use common sense to realize that. Let's say you only found this one. We know we're looking for two numbers, right? Let's say you only found this. You can easily find this as well. So let's say you know 85. Here it is. Here is my interval, right? These are my two locations in green. And I was able to find the first one, the lower bound. Since you know the mean, you can take advantage of the mean to get this location. If this is 85 and change and this is 110, that distance has to be 24.861 by doing 110 minus 85.139. Once you find that distance, duplicate it, because this number has to be the midpoints between these two. Okay, so this number is equidistant from these two guys. And then, once you know that distance, you add it to 110, add these two, you get this one. Conversely, let's say you only found the upper bound, okay, which is 134. It's not hard to get this one. We know the distance between 110 and 134 is this by doing this minus that. And then you subtract this again, 110 minus 24.861, and that should give you 85.139. Okay, so that's just, you don't have to use this method. In fact, it's probably longer. But it's important that you do both to get your interval. Let me just say one more thing quickly that I forgot to mention. Actually, yeah, here. So now we found my interval. Let's say you want to double check to see if my interval is true. So this is the interval we just found. 85.139, comma, 134.861. This is my interval. If you want to know if you are correct, you can double check your work. How? You go to norm CDF and you write your interval that you just found, this one, here, 85 points, 134 points, mu sigma, and see if you get 68%. Because if you don't get 68%, it means you made a mistake with either this one, or that one, or both. Make sense? All right. So this is enough for today. I will talk to you next time.